12.6 Circular and periodic functions. So this lesson's all about a unit circle, which we talked about last class, right? So remember, this is a unit circle. Has a radius of 1, hence the word unit. So a lot of this actually has been reviewed. Like we talked about, right, sine is normally y over r, which is the radius, but if we're talking about a unit circle, the radius is 1, so we just talk about sine equals y, sine e, and cosine equals x. We call these things circular functions because they're defined on a circle, hence circular functions. Now, here's a problem we're going to do, and honestly, we're never going to do a problem like this because it's too easy, but here's the idea. So this is a side of a unit circle. So that means if I do a point like we normally do, right? So 3/5 and -4/5. Ooh, that's not a straight line. So 3/5 is over here somewhere. -4/5 would be down here somewhere. So this point would be over here. That'd be 3/5 and -4/5. And we do what we always do. Connect it to the origin and connect it to the x-axis. Right, and if I do that, how much moved on here is my x value, so 3/5. How much moved up and down is my y value, so -4/5. And since this is a unit circle, my radius is going to be 1. I could do a squared, b squared, c squared, but I'm telling you right now it's going to be 1. So they want you to find sine and cosine. Well, sine theta is, right, SOHCAHTOA, opposite of hypotenuse, so -4/5. Cosine theta is adjacent from hypotenuse, so 3/5. And done. Right? Because on a unit circle, I don't have to worry about this. Sine e is the y value and cosine is the x value. That's it. Done. So if I was doing this one, hey, it's a unit circle. So what's sine? Well, sine is the y value right there. That's sine. What's cosine? Cosine is the x value. So write that right there. Done. So you're not going to get one of those. Too easy. Let's get to the next part then. Part 2, periodic function. So a periodic function is a function that has y values that repeat in regular intervals. So it's just a graph that repeats itself. Like right here you'll see it goes down and it goes back up. It repeats itself every 36 degrees. So then goes down, goes back up, goes down, goes back up. The length of time it takes to repeat itself, or what we call one cycle, is also known as a period. So the period of this graph right here would be 360, because that's how long it takes to repeat itself. So next, let's determine the period of this function. So the whole idea is how long does it take to repeat itself? So let's start at 0. It's the easiest way. You can start anywhere, but let's start at 0. We go down, we go across. It still doesn't repeat itself. Like if I just kept on doing that, it would be down, across, down, across. I got to get back to here basically. So down, across, and then up. Now it repeats itself. Now you can see it's always that graph over and over and over again. So that's my period. My period's pi. Let's do the same thing here, right? Again, you can actually start anywhere you want. Like let's say I want to start down here. Let's start at 2. Let's find a period. How long does it take to go back down to that spot right there? So in this case, go up, go back down. I can't draw a line to save my life. And there. Oof, this is a lot harder than it looks. Let's make it more of a fool of myself. Anyway, it's right there, right? It's 2. The period's 2. It takes 2 x values before it repeats itself, right? You see something here with 6 and 8, right? This repeats itself. 4 to 6. It's every 2. Now look at this one. So let's try to find a period. So we're going to start at the origin. That's usually the easiest. And then we go up and we go down. Now that's not a period, because if that was a period, my graph should look up and down all the time. Right? That's not what's going on here. It's going all the way back down. Right? And again, even though I hit the exact same spot I started, it's not repeating the same process. So we went up, we went down, we keep on going down, and then we go up again. Now we're about to repeat ourselves, right? So it's up, down, up. So it'll be like this. So that's my period this time. So my period here is 4. And that's all a period means. That's all a periodic function is. A function that repeats itself. Why are we learning this? Because that's when we start graphing sine and cosine next section, that those two things are going to be periodic functions. Same thing with tan. Just mean graphs that repeat themselves because they're built off a circle. So quickly, let's graph a function with a period of 4. Now again, it has to be a function. So watch out, like that's not those are functions. So, okay, well they're all functions. So graph a function with a period of 4. So I don't know, you can do anything you want. Let's start here. I'm going to go up and then down and then up again. Let's say that's at 4. Not the best graph in the world, then you just keep on repeating it. Okay, that was an accident. Right, and then keep on doing that. And it keeps on going on forever. So there's a periodic function with the graph, with the period of 4. And it could be anything. A quick application problem. The height of a swing varies periodically as a function of time. The swing goes forward and reaches a high point of 6 feet. So let's say we have a swing. Right, so it's saying, let's say that's the swing part. It goes to a high point of 6 feet. And it goes backward and reaches 6 feet again. So then it swings around again. I get another 6 feet. Its lowest point is 2 feet, so that's like right here, right when we start. The time it takes to swing from its high point to a low point is 1 second. So like the time from here to here is 1 second. Which means the time from here to here is 1 second. So A, how long does it take to swing to go forward and back one time? So I guess you start here, go forward and back. That'll be 2 seconds. Graph the height of swing as a function of time. So this is interesting. That's why I want to do this one. So let's graph the height as a function of time. So we start off, right? If you're starting from a swing, you start like right here. So at 0 seconds when we start, we're at 2 feet. 1, 2, 3, 4, 5, 6. So this is 6, this is 2. So again, when we start, we're at 2 feet. I don't know, then let's say your dad, your mom pulls you up to this and lets you go. So at 1 second, you're at 6 feet high. Right, so it's 1 second. So 0 here, 1 second here. Then we go back in, that's 2 seconds. Then we go forward again. So at another second, we're at 6 again. And we're going to go back. And it's going to keep on doing the same thing. So our graphs look kind of like this. And it just keeps on going. So it's a periodic function. Now look at what our period is. It is 2. Right? It takes 2 to repeat itself. So you go up and then down. Up and then down. So that's the idea. So the last thing we're going to talk about is a brief review of the unit circle. So remember, this is a unit circle. Lots of ways to do it. Most people are either team table or team triangle. So let's do a couple just to practice again. So cosine of negative 3 power of 4. You do this any way you want. But no matter what you do, you want to know how to graph it. So there's pi. It's a negative, so we're going to go down. So this will be negative 4 over 4. Now again, we're trying to get to negative 3 power of 4. So I haven't reached here yet. I'm a little short, so I'm right there. That's negative 3 power of 4. Now again, from here on, so you do a table or you do a triangle. It's up to you. Either way, you should know it's a 45-degree angle because it's power of 4. And then I'm going to do a triangle real quick. So that's negative 1, and rad 2. Then cosine will be SOHCAHTOA, so adjacent right hypotenuse. So let's look at sine 420. Right, so in this case, right here's 0, here's 180. We're doing degrees this time. I gotta get all the way to there. So this is 180. Add another 180, you get 360. Now, if you're not sure where it's at, so it's 180, so 0, 90, 180, 270, 360. 360 plus 90, let's do another one, it's 450. So it's in here, in between here somewhere. And then we do what we always do. Figure out the angle. So in this case, it's 60. Now again, after you're doing a table, it's the easiest one. Like, oh, 60, just look at it. Sine of 60 is rad 3 over 2. Done. You're in quadrant 1. If you're doing a triangle, that's rad 3. This is 1, this is 2. Sine is opposite right hypotenuse. Rad 3 over 2. Last couple. Sine of 13 pi over 6. So here's 0, here's pi. 6 over 6 is right here. If I go around again, this is 12 pi over 6. Right, because 6, another 6. I got to go 13, so I'm a little bit more. Hey, I'm back in quadrant 1. And since it's over 6, it's a 30-degree angle. Again, if you're doing a table, you're done. Just look at it. What is it? In our case, it's 6 over 30. So I notice this side is 1. Hypotenuse is always 2. And this is radical 3. Sine is opposite of right hypotenuse. By the way, that's why sine's my favorite. Because once I see 30, I know what the answer is. 1, 2. And eventually, when you get good enough, you don't have to draw anymore. Like this one, sine of negative 60. So in your head, you kind of go, wait, it's 60. What's opposite 60? Rad 3. Hypotenuse is 2. And then since it's negative, that means you're going down. So negative rad 3 over 2. You kind of draw in your head. Or look at the table in your head. Anyway, last one, 540. Same thing we did before. Let's draw it. 0, 180, 360, 450, 540 is actually over here. It's on this point right there. So remember, that's special. If you're looking at the table, you don't have pi. You don't have this point right here on your table, but you do have 0. So you just negate the answer for 0. If you're doing the triangle method, you got to know what that point is. It's a unit circle. We went left 1, so it's -1, 0. Cosines the x value, so -1. And that's it.